Hello and welcome to All Space Considered, everybody. Thank you.
Yeah.
I'm Dr. David Reitzel, astronomical lecturer here at Griffith Observatory. With me is Laura Ibran and Jared Head, and we've got a great show for you tonight. Yeah, thank you. All Space Considered is the third Thursday of every month. It is brought to you by the Department of Recreation and Parks in the city of Los Angeles, and we always like to thank Griffith Observatory Foundation, our exclusive nonprofit partner. So many members out there support what we do. We thank you all. Those that have made donations, we thank you as well. So we appreciate you. Like I said, we're the third Thursday of every month, and tonight is Thursday, April 16th, and we've got an amazing show from the Leonard Nimoy Event Horizon Theater here in Los Angeles at Griffith Observatory. We're going to talk a little bit about Yuri's Night celebrated here at Griffith and what Yuri's Night was about. We'll talk a little bit about NASA's first moonshots, what they did going to the moon way back when. That's right. And then we are going to turn to Artemis II, of course. An amazing mission just completed, and we're going to bring you all about Artemis II, liftoff to splashdown. We're going to talk about the sights of the lunar flyby. We've got the solar eclipse coverage and more, so stay tuned for all of that. And then we are thrilled tonight to have with us the fabulous Jameeka Marshall, Program Manager of Shadow the Scientist, to talk about making science research accessible. And she's going to be up here to talk about what all that means, and we're really looking forward to that tonight. But first, let's kick off the show with a launch. So if we could dim the lights, let's show our
Crank it up
to launch.
That's right. Put it to 11.
So that is Artemis on the way to the moon. So we will turn to that. Just incredible footage.
Yeah, right.
Yeah, just amazing footage from my folks at Cosmic Perspective. Yeah, you all right, Jared?
Yeah, I'm good. Now that we got that out of the way.
Yeah. Well, here at Griffith Observatory, we were very lucky to celebrate Yuri's Night on April 11th here at the observatory. We hosted the celebration, and hopefully folks were here for that. It was a really good time. There was an inflatable shuttle on the front lawn even. It was pretty cool. But I want to talk about what the celebration was about. It was about Yuri Gagarin, Soviet pilot and cosmonaut, who was the first successful crewed space flight, and he orbited the Earth. He traveled on Vostok 1, and his flight lasted about 108 minutes on April 12th, 1961. And here he is, heading up into the spacecraft, the Vostok 1, strapped in, and here's the launch. This is a lot of footage people haven't seen. Some of the stuff was declassified fairly recently.
It's an R7 vehicle, which is basically an ICBM that they put a spacecraft on top of it.
Yeah. Yeah, so just incredible launching up into space. All those years ago.
And that rocket is so good, we're still using Russia's still using variants for their Soyuz rocket today.
Yeah,
so.
Absolutely. And here's what it looked like out the window. Indeed, the curvature of the Earth is seen clearly, and up in space. Now, the flight itself, notice he avoided Europe and the United States. They planned it that way. I also think they flew a lot over the water. I'm sure they had their ships out there that could track the mission,
yes.
Their radio receiving ones to be able to talk to him as he flew over. So all of that was planned. Came back to the Soviet Union as a hero, title of Hero of the Soviet Union. So truly a remarkable figure. And I love this quote from him. "Looking at the Earth from afar, you realize it is too small for conflict and just big enough for cooperation." So that's exactly. Yeah, he passed away on March 27th, 1968, when his MiG-15 that he was piloting with a flight instructor, Vladimir Sergeyogin, my Russian's terrible, I'm sorry everybody, crashed near the town, crashed in Russia. So, but he's celebrated to this day worldwide as the first human in space. Now, of course, the United States had a program to get a human into space. Alan Shepard was scheduled to go months before Yuri Gagarin, actually, and they were working on the rocket. There were delays, and he didn't end up launching until May 5th. So just a few weeks later, in 1961, Alan Shepard on the Mercury Redstone 3 became the first American and the second person to get into space, but he didn't orbit. It wasn't until John Glenn that we made a full orbit. And that was with Freedom 7 that the full orbit happened. Of course, this eventually led to Apollo. There was the Gemini missions in between. We don't have time to cover all of that, frankly. But the Apollo missions, they led through the various launches all the way up until Apollo 8 that finally went to the moon and captured this beautiful picture that's known as Earthrise. And the Apollo astronauts, of course, 3 men fly around the moon for only 70 miles from the surface. They liken it to dirty sand. And they head back to Earth after circling the moon 10 times. So it was a really remarkable mission to go there. It was not a free return, which we'll talk about what that, maybe Jared will mention that later, we'll see. Yes. But they did go their orbit, and then they had to boost themselves and come back. Griffith Observer, of course, celebrated this, our own magazine here at Griffith Observatory. And eventually, we did land on the moon. Apollo 11, we put boots on the moon, walking around. Laura May, this was even international.
This was, of course, international, not just in the U.S. This is a this is a old newspaper I bought at auction some years ago from France, of course, François, and it says, "Now danger, people ripping up the moon." And it was, of course, it was mentioning of the thought at the time. Of course, we think back on this incredible space race, but there were geopolitical reasons, of course. And so there was a lot of debate and anxiety over who was going to own the moon, and this is still current, right?
Mm-hmm. It's going on. And of course, we celebrated the moon landings here at Griffith Observatory. You found this in our archives.
Yeah, so this was in our archives. This is our Golden Moon anniversary. So 50-year anniversary of the moon landings. I was not there at the time. But that little, that Earth you see in that rocket was moved every single day closer to the moon or to Earth. To celebrate. We've had, I couldn't find any images actually of this, what happened, of course, in the 60s. I presumed that there were a lot of people here maybe looking at telescopes of the moon.
Looking at the moon through a telescope, sure.
If you were here at that time, please let us know, email us.
Now, of course, NASA moved on to the shuttle program. We needed a workhorse to be able to build the International Space Station, to do satellite work. It was planned to launch satellites from its cargo bay. Ended up being a little bit of a problematic spacecraft, as we know, 2 tragedies that we lost Columbia and Challenger through the program. But it also achieved amazing things. The servicing of the Hubble Space Telescope, the astronauts have said that is what they feel was some of their most important work, to allow astronomers to use this fabulous instrument that had a flaw. Without their work, we wouldn't have been able to fix Hubble. And then they went in and updated the instruments time and time again to make it more and more modern over the years. So due to the shuttle, we were able to keep Hubble as important as it is still to this day. Yeah. Of course, the shuttle helped build the space station. This is our own Endeavour shuttle, Los Angeles' shuttle, docked to the space station. This was taken by a Soyuz that was flying around looking at it. So an unusual view. You normally don't see the 2 together like that. You often see the space station from the shuttle or the shuttle approaching the station, but the 2 together like that is pretty cool. And of course, the space station itself was built by NASA, so all that happened, and amazing research happened on board. I used to kind of, when I was a graduate student, wonder, well, what are they really going to do up there? Well, they did some amazing work. They've done some X-ray astronomy, they've learned about biology, they've learned about human space flight, of course, and made it possible for us to understand how to stay in space a long time. So it truly turned into an experimental lab that has been invaluable to science. It's been important. But we're here to talk about the Earth and the moon and going to the moon. And this is actually the trajectory that the Artemis II spacecraft took to get there. And you'll notice Earth has this magnetic field around it. It protects us. It creates the aurorae, but it also keeps dangerous stuff. But look, there goes the spacecraft, flies right out of there, out into space. and it's going to head over to the moon and fly around it. Well, Laura May, that seems kind of bad.
Kind of dangerous, right?
Kind of dangerous, yeah.
So as we venture deeper into space, we aren't just leaving Earth, we're also, as you mentioned, we're leaving our atmosphere and our magnetic field, more importantly, and that means exposing not just technology, but also humans, little delicate humans, to all of the particles that travel through interplanetary space. And some of those come from the sun, such as these, the solar energetic particles. They come from solar flares, and they follow this spiral-shaped interplanetary magnetic field. Let me see if we have the, oh, no, we do not have the video. But some also come from much farther away, such as these cosmic rays. We have a little detector here, in fact, for cosmic rays. And they're mostly protons that travel at the speed of light, and they can really damage human DNA, unfortunately. And that's actually one of the biggest dangers because they're much more energetic and they're much harder to shield against. So these solar storms will last a short amount of time. You can shield yourself, but it's a little bit harder for the cosmic rays. So.
Yeah. So this was the trajectory that Artemis 1, the first usage of this technology. It didn't have people on board, but it flew out to the moon, it tested the equipment, but more importantly...
It had, in fact, it had some fake people on there.
Fake people.
So they flew some dummy astronauts with all sorts of sensors on them. I know, it's
the Blue Man
it's
Group.
the Blue Man Group, right? They're called Helga and Zohar, in case you wanted to know. And they were fitted with about 5,600 passive sensors, 34 active radiation detectors, because this was a 25.5-day mission around the moon and back. And they found that the orientation of the spacecraft can halt the levels of radiation, the levels of radiation they were receiving, and they also had sensors throughout the capsule to be able to test where it was safer. But overall, they were able to validate the safety of the Orion capsule. And there are also teams on Earth right now, as that Artemis 2 flew out there, that are constantly monitoring solar activity, flares, sunspots to see what's actually going on. And
yeah. This was the heat shield of Artemis 1. They looked at it. It was a new heat shield, a new design. It came back. The spacecraft survived, but chunks fell off of it. It had some problems with what's known as spallation. I'm going to point it out on the screen. For those at home, it's just to the right of center. But for those here in the audience, you can see right here, there's a chunk missing from the heat shield. And there's several other places on there that are missing little pieces as well. What happens is this heat shield keeps itself cool by having the material, when it gets hot, gives off gas. That gas can carry away the heat. It protects the spacecraft. Well, it turned out the trajectory they took coming back into Earth, it took them up out of the atmosphere for a while. They came back in, they did a little bit of a skip. It was planned, but it allowed the stuff to stay hot too long. And the gas built up down low, and it sort of sputtered, breaking it out. That's what they thought was happening. So they decided, let's fly the same heat shield for Artemis 2. Well, not quite. They did look into it, and they made some plans to try and make it safer, but I want to leave it there as was this safe to do? Was it smart? They have a new heat shield for Artemis 3. The next mission, they redesigned things to make that gas be able to escape easier, but they did make some changes, and I think most of you know that they worked, otherwise you would have heard more.
Yes.
But anyway, this leads us right to the Artemis 2 mission. So Jared, how did it go, and who was on board? Tell us all about it. You know, out to lunchtime, Jared.
Yeah, it's time for your extended out to launch.
that's right.
So
Finally, Jared gets
finally, I get to take control of the show. Right. Who cares about astronomy? It's all about space flight. No, I'm just kidding. We love astronomy for now. All right. So, but Artemis 2 was a mission a long time coming for us. You know, with Artemis 1, felt like ages ago, finally getting a chance to do this, and finally getting a chance to return humans to the moon for the first time in 53 years as well. Apollo 17 in December of 1972 was the last time humans were at the moon. So to be able to put us into that proximity, there were so many people who just weren't around. I wasn't around. At that time, I don't even think my parents were around at that time. So yeah, it was just incredible thing that happened. And with our 4 astronauts that were on board, I think you couldn't have asked for a better crew with what you had. So you had Reed Wiseman, who was the commander. He's a U.S. Navy test pilot. Selected to NASA in 2009. He was a flight engineer on Expedition 4041 at the space station, 165 days in space, and he was the chief of the astronaut office from 2020 to 2022. So definitely a little bit of what we call the right stuff. Also, Victor Glover, the pilot, who's local from Pomona, went to Cal Poly Pomona as well. So SoCal represent.
Come see us, Victor. Be our guest.
Yeah, come on,
Please.
Victor. If anybody knows him, get us in touch. He's a U.S. Navy combat veteran and test pilot as well. Selected to NASA in 2013. He was a flight engineer for Expedition 64 and 65 for 165 days and actually did 4 spacewalks while he was up there. And he's also the first person of color to fly beyond low Earth orbit as well. So about time for that. And then Christina Cook, the mission specialist 1, worked at Johns Hopkins Applied Physics Laboratory Research. Also as a U.S. Antarctic fellow, so did a lot of work in Antarctica and the Arctic. Selected to NASA in 2013. Was a part of the Expedition 6061 mission as a flight engineer. Spent 328 continuous days in space. She holds the record for the most days continuously in space for a woman. Did 6 spacewalks, and also about time as well, first woman to fly beyond low Earth orbit as well. So there's a lot of about times and firsts on this mission, let me tell you. And then Jeremy Hansen, mission specialist 2, a Royal Canadian Air Force fighter pilot. He was selected to the Canadian Space Agency in 2009. This was his first space flight, so imagine being a rookie and you're like, oh yeah, you're going to the moon for your first assignment. So yeah, not bad, right? And he's also the first non-American to fly beyond low Earth orbit as well. So yeah, it's amazing. Turns out the Commander Reed was the most boring person out of all of them. I'm just kidding about that. But let's go ahead. Let's take a gander at some beautiful footage that we were able to watch here. So let's take a look at this aerial footage of the launch here.
I love that noise.
Yeah. And if you take a look over on the left, you can see the compression from the sound, the actual acoustics.
Wow.
Like compressing the air there and having it vapor out. That's so cool.
Yeah.
But now comes the really good one that we're very excited to show everybody. So hold on, everybody. We're gonna not talk for most of this one.
Yeah, this is thanks to my friends at Cosmic Perspective who provided the video for us.
All right, here we go. I will try to keep myself as under control as possible.
How far downrange is it at this point, do you think?
Oh, at this point, it's a couple miles above what an airliner would be flying at by this point. So
keeping this in frame like this is just crazy.
Yeah, and this is going to stick with it all the way to booster separation, which would be usually at about an altitude of 40 miles and probably about 60 to 70 miles downrange. So just the amount of detail we're going to get out of it is just astonishing.
So yeah, the video itself, they transitioned to music, so we got rid of the audio so that we could talk
Yeah.
about what's going on, or that Jared can explain.
Yeah. So this was April 1st, April Fool's Day of all days.
To launch.
And we were a bunch of fools for thinking it wasn't going to launch because they hadn't done a fueling test ahead of time after repairing the issues in February. And a lot of us, myself included, thought, boy, that's dumb.
Hydrogen leak, what me worry?
Yeah, hydrogen's perfectly fine. But turns out it ended up working out excellently, completely what we call clean flow into the launch. So basically no major issues. They had a range issue and they literally pulled out an old piece of equipment from the space shuttle era in order to fix it.
Wow.
So the space shuttle, the gift that keeps on giving, even this far down. But yeah, beautiful launch, just gorgeous, like exactly right where it needed to be, right on trajectory. Literally hit essentially the rocketry equivalent of a bullseye in putting the Orion into orbit around Earth, and it just does not get any better than this. As an engineer myself, this is just like, this is the good stuff. So this gives me the fizz. So
Do you know what exactly they were using to be able to have such smooth filming of this?
A lot of times what they do is they actually will have very large, like 12 to 16-inch telescopes mounted on what were at times anti-aircraft gun turrets in order to very smoothly track them like this.
That makes sense.
And if I remember correctly, with Cosmic Perspective, your friends here, Dr. Wrightsall, this is all being done by hand as well. So.
It might be. They had a whole van with multiple cameras and the multi-cam. They work with Everyday Astronaut, Tim Dodd. So
so we can see the 2 solid rocket boosters and 4 RS-25 engines. So basically, reset or reconfigured space shuttle main engines. Once the boosters run out of fuel, about 2.5 minutes into flight, they start to do what we call the tail off, which you get to see it a bit reddish right there, and then you'll see the separation motors fire very soon here. And when they separate, they fall back in the ocean, and they're, unlike shuttle, these are not reused. So they're one and done. So there go the boosters.
So if you have a boat, you can catch it and keep it as a souvenir.
Yeah, you sure can try.
No, you can't.
I think some aircraft may come out and have some words with you.
I think they might. But that is just amazing footage. So we saw from launch right in front of us through booster separation.
Yeah, that's
insane.
incredible. And then this is a camera from NASA on board of the vehicles. We watch the boosters go back. We can see Florida, the coastline back there at the Cape. And at the bottom there, you can see the shadow from the plume of the solid rocket boosters right there as well. So those boosters, they create quite a plume, unlike the RS-25 engines, which actually don't make much of a plume. And then there's separation of the upper stage. So that's the service module of Orion right there, which was made by the European Space Agency. So shout out to all of our homies in Europe. Thank you so much. Appreciate the ride. And then they went into high Earth orbit for a day. They actually ended up setting the record for the highest orbit by humans, over 40,000 miles above the surface of the Earth. And then they came close down to the Earth and came translunar injection, which was the burn to go to the moon. You burn your engine, pick up your speed. They left Earth at about 23,000 miles per hour. They were cooking, to say the least. So, and then on the way out, Reed Wiseman, the commander, took this photo titled "Hello Earth." And
Hello Earth.
I love the love for the Earth that was coming down. With this. So the sun was actually behind the Earth relative in this image right here.
And a little Venus in the
Yeah,
corner.
little Venus. I think we've got a diagram a little bit later of another blockage.
Another, that's right.
There, and then this was a regular shot, and then Reed opened up the exposure a bit more, kind of lengthened the shutter speed on it, and this was the shot that he was able to get here with it. So we could see a bit more detail there. We could see Africa over there on the left. We could see just a little bit of Europe right there. You can see Spain in that area. South America over on the right side of the Earth. That sort of, those bright lights in the middle of the Earth are reflections off of the windows. And maybe my favorite detail is up here at the North Pole, and down at the South Pole, aurorae. Right there. You can actually see the aurorae on the limb of the Earth's atmosphere there. So
crazy.
A blue marble photo for the Artemis generation.
But
so
that's Earth at night.
yeah, that's Earth at night.
So
If you look over at Europe, you can see some of the city lights, some also northern Saharan Africa and Central Africa there, and some of South America as well. You can see some of the city lights there. So absolutely stunning views. This one, Christina Cook, doing what I would probably do the entire time, which is look out the window at the Earth. I mean, how could you not?
It looked like an anime shot when I saw it.
Yeah.
It looked like it was from a sci-fi or an anime because it was such an incredible image with the hair.
Yeah.
And
One of my friends was like, "Which Gundam series is this?" And I was like,
Exactly.
I don't know.
Right.
So, and then this one, I love this one too. Just being a hardware person, I love seeing the actual flight hardware in action. And there's the Earth peeking out of a little window
amazing.
there. And then, spending a couple days cruising out to the moon, doing various things such as having a toilet work and then not work, and then work and then not work, and Christina Cook becoming the official plumber of Orion capsule integrity as she troubleshooted the problem there. They did eventually get it working. They do think that there's sort of a valve issue. It wasn't a pressing issue. It wouldn't have stopped the mission even if they were landing on the moon. But hey, it was probably not particularly great.
Yeah.
And then also, Microsoft Outlook that was on board of the spacecraft was not working particularly well.
Terrible on Earth and in space.
Yeah, I was just going to say, same as it ever was. So, so there it goes. And then my personal favorite photo came as they were coming up on going around the moon, which is this photo right here. This is my favorite photo of the mission. Looking at that lunar surface with a very small crescent Earth in the background and that hint of a window there letting you know that you're riding along with them. And I think that's what really made this mission so special, is that the way we were able to interact with this mission was truly unprecedented. We were riding along with the crew as they came up. And this was a photo that was taken by one of the cameras on the solar array of the Orion spacecraft right at loss of signal. So basically when they went around the moon and they could no longer talk to the Earth for almost 50 minutes as they were going around the far side of the moon there. And then another photo, Earth set. So for Apollo 8 we had Earth rise, but for this we now have Earth set. And just like the beautiful contrast of the stark landscape of the moon with our home right there. Yeah.
And now we've reached the mostest point of our show.
Yes.
Indeed. So the mostest, for those that are confused, each show we try and pick yet another moment where astronomy, astrophysics, space travel has eclipsed a previous moment. So it's the new mostest, is what we decided to call it, laughingly. Well, this, of course, is people traveled further from Earth than ever before.
Yeah. So Apollo 13 was the previous mission that had done that. They were on a free return trajectory. And they flew about 110 miles above the surface of the far side of the moon. So about 246,000 miles away from the Earth at that time. This mission was on a free return trajectory from the start. So actually the first ever mission that we've launched to the moon with people that had a free return trajectory from the start. Apollo 13 was not intended for that, but it was put onto that after the explosion of the oxygen tanks. This altitude, 4,000 miles above the far side of the moon, so it was 252,000 miles away. So we have a new absolute altitude record with that. So
Very cool.
Yeah, no one on your Find My app will be that far away ever.
It's a little lunar crescent.
That's Earth.
Yeah.
Sorry,
not lunar.
That's a little crescent Earth.
Earthly.
That's us. So everybody you know is there. So everybody you like is there. Everybody you don't like is there. All your pets are there. All your friends are there.
Tacos.
And everyone. Yeah, tacos. Thank goodness. Let me tell you. So I'm appreciative of that. So that's where Taco Tuesday happens. For anyone who may be zipping past right now, aliens or anything, come on down, Taco Tuesday.
Nothing on the moon,
fantastic.
though. Nothing on the moon yet.
Yeah. Please invite me to Taco Tuesday on the moon. I would like that.
One day, I hope.
And these are just some of the, this was one of the really great far side images of the moon.
Wow.
So this was a part of the moon that hadn't been seen by human eyes before. The Apollo spacecraft, they orbited the moon, but they went at specific times, which means that actually a vast majority of the moon was in darkness when Apollo was there. And also they orbited at a very low altitude, so they didn't actually see much of the moon out the window of their Apollo command modules or lunar modules. And of course, when you're walking around on the surface, you don't see a lot of it either. So, so this was an area that hadn't been seen by human eyes before, and now it's been seen by 8 human eyes, 2 or 4 pairs. And they were busy during the flyby. I don't know if anybody was watching NASA's channel, but they were hard at work. So there's Reed and Victor looking out the windows, taking imagery, and then they would trade off. They do about like 20 to 25 minutes of work, and then they trade off, and Christina and Jeremy would go to the window and do their work that they needed to. So they all had a set of targets to look at and to take incredible images. Like this right here, like that is just unbelievable. The sharpness of that.
Yeah. Wow.
Like orbital spacecraft don't get this level of sharpness. It's absolutely astonishing what they were able to accomplish, and I'm very much looking forward to the scientific results that come out of this as well, especially with the flashes that we saw of the meteorite impacts. Or
and
meteor impacts.
They were trained, from what I read, also for photography. So they don't just do their regular training. They're trained to know how to take good pictures, which is great.
Yeah, the really neat, if you ever watch the video of it, they basically took them into a room, had a really big screen, and then had them photo the photos on the big screen, and it worked. Because look, amazing.
Incredible.
Incredible work.
And you might have seen this picture of the astronauts, and this is from the flight, because guess what? They really did actually get to use those glasses. They saw an eclipse. Astronauts are just like us. They use the little paper ones, mostly for weight. And this was the first use of little eclipse glasses at the moon to safely view a solar eclipse. Now, eclipses seen from the moon were imagined. This is an illustration. It was imagined long before we could actually witness them. And this is a painting by Wilhelm Krantz from 1893. Right? So people were already thinking about what this would look like. What you're seeing is technically a solar eclipse from the moon. It is Earth eclipsing the sun, right? So it's the other way around from there. And the first one that was seen in space was by a robot in 1967, the Surveyor 3 probe, and he was able to capture these incredible images, a little bit grainy, but, let's see, there we go. And finally in 1969, I don't know if we have the video or not. There we go. We had the first humans to ever see an eclipse from space with the Apollo 12 mission. It needed a bit of an update, I think, and so we got that. So on April 6th, the Artemis 2 crew, right? It's incredible.
Yeah.
So they witnessed their own eclipse. Wow. They had about 54 minutes of totality because, again, keep in mind, they're not on Earth. They're out in space, so they're also moving. And there are some stars typically too faint to see in this image when you're imaging the moon. And with the moon in darkness, stars, can pop out a little more. And you have the faint glow of the near side of the moon that's visible in this image that's illuminated by reflected light off the Earth, what we call Earth shine. So this is also, by the way, an opportunity to do science about both the sun and the moon, because what they're seeing, of course, is this solar corona that we all try to look for when you're eclipse chasing. You're trying to see that on Earth. So this is to show you a little bit of what you're seeing in this image, where that Earth shine comes from. You've got Venus in frame. You've got this light coming, and you've got Saturn, Mars, Venus, and you even have Neptune in this image. So one spacecraft, it wasn't pointed out, it's very, very small. Got one spacecraft, technically 2 light sources, and you've got 6 celestial bodies in this image. So a pretty amazing eclipse image. And this was the very end of the eclipse, and it shows the sun just beginning to peek out from behind the moon. And it might actually be showing us something that we call lunar horizon glow, which is created by lunar dust. And of course, they were asked numerous times to look out for lunar dust. That's really, really important if we were ever to have a base there and for astronauts to land. And
all of the Apollo astronauts noted seeing lunar dust, lunar horizon dust. So that was, hopefully that's what it is.
Hopefully
we'll
so.
Find out. So, yeah. And then just this gorgeous image of Earth. This is our Earthrise, as a thin crescent Earth comes out of the absolute darkness of the moon below it. So gorgeous what they were able to see with that. So eventually they had to come home though, right? So another 3 days to come home. They did some tests on the way home, like radiation checks and other things like that, seeing how you could handle radiation, see if you could sit in your suits for a while. So their suits, they can actually stay in them for up to 6 days in case there was a problem on board of the spacecraft. Doesn't sound comfortable to me, but you could do it if you needed to. And then eventually they came home, and it was time for what many people were describing as the scariest part of this mission, which was atmospheric entry.
Well, it was time to test that heat shield.
Yes, time to test it. Yep, and that test, unlike launch where we could delay it and scrub it or anything, this one, Isaac Newton was in the driver's seat. So it was happening whether you wanted it to or not. And this is what it looked like out the window in those opening seconds of that. And you can see the Earth there with the blackness of the sky. And they eventually were able to actually see the plasma build up around it, and then went into a radio blackout for 6 seconds.
13 minutes, 10 seconds.
So you'll see that like reddish glow start to build up. That's the superheated air that's being compressed to almost 5,000 degrees Fahrenheit.
Wow.
Enveloping it, and then whoosh, there it went. You lost signal because that plasma doesn't allow radio signals to travel through it. Eventually they came through the atmosphere. 6 minutes radio blackout came out of that. And then about 10 minutes after atmospheric entry, we had this, which was the deployment of the drogue parachutes, which drogue parachutes are used to stabilize the capsule coming in, just in case it was off kilter or something. As you can see, it was falling perfectly fine. But those drogues keep it nice and steady, and then came time for the 3 main parachutes to deploy. And we can see them, they open in a sequence where they get bigger and bigger. We call that reefing. So they reefed out very nicely. And then they went from 24,664 miles per hour at the top of the atmosphere to landing in the ocean, splashdown 14 minutes later at 19 miles an hour. So, and here's that beautiful splashdown in the Pacific Ocean just east of San Diego. And that ended humanity's return to the moon. So it was really nice. Very well done. Looked to be a textbook mission. And so far, the first looks that we've gotten at the heat shield of integrity, it appears that the not using a skip entry, just using a ballistic entry coming in as it was, worked perfectly. So it appears that there was minimal damage to the heat shield compared to Artemis 1. So
good to know. Well, of course, the astronauts emerged from the craft, greeted folks that as heroes, essentially, even brought their little plushie with them. What was it called again?
Rise.
Rise.
Yeah. Their 5th member, they were saying, Rise.
Remember Rise.
So
there they are with the craft, and then, of course, showing some love.
Yeah.
Now, I was looking for a solid metric on whether this was successful at inspiring people to care about space and really, think about what we can do, and the answer is yes. Kerbal Space Program. It's a video game. You can download it on Steam, and this is the rate at people which were downloading it. It was released in, 2014 or so. 2015, there was a bump where a lot of people played it. It was played along the way. It's very fun. It has real orbital mechanics, a little Kerbal planet. It's a lot of fun, actually.
Yeah.
Anyway, you can see a huge spike. More people started playing Kerbal Space Program due to Artemis than ever. More people downloaded it over this period of time than ever. So for a crazy metric, this is showing that people cared and wanted to participate even, because this is participatory. Let me back it up just a sec. Anyway, now let's hear from the astronauts. They had some amazing things to say about the mission, so we have a few short little videos about their thoughts on it.
Being 200,000 plus miles away from home, like before you launch, it feels like it's the greatest dream on Earth. And when you're out there, you just want to get back to your families and your friends. It's a special thing to be a human, and it's a special thing to be on planet Earth. Thank you.
And I wanted to thank our families
for everything that he just said. So great words, great words, great words. I love you, but not just those 5 beautiful cocoa skin ladies right there. All of you.
Yeah, very emotional.
The reason I had them form up here with me is because I would suggest to you that when you look up here, you're not looking at us. We are a mirror reflecting you. And if you like what you see, then just look a little deeper. This is you. Dude, come on.
I thought a lot about that line. They should have sent a poet from Contact, and it seemed like they sent 4 poets.
Yeah, 4 poets.
They did.
And then I played this a little out of order, but I wanted to end with this comment. Oh, click to play. Here we go. It's telling me what.
I may have not learned, I know I haven't learned, everything that this journey has yet to teach me. But there's one new thing I know, and that is Planet Earth, you are a crew. Yeah. Thank you.
Yeah. And I like to think that she meant more than just the humans on Earth. It's everybody on Earth, all the animals, all the life. And she went back and played with her dog, of course. And I love this picture. I love this because of the water of the earth, the land of the earth, the clouds. She was seeing that from afar, and one of the first things she wanted to do was go play in the ocean with her dog. So it's just cool. Of course, an inspiring mission, Artemis 2. Artemis 3 will be a low Earth orbit mission. It's not going to go nearly as far. It will test the landers that will land on the moon. That's slated for about a year from now or so. Yeah. And then in 2028, we will return to the moon and use the chosen lander. They haven't picked it yet, but the chosen lander will land humans back on the moon. And then hopefully later that year, they will look to establish a permanent presence of humans on the moon. So things are moving forward, and it is super, super exciting.
Yeah.
Very much.
What a great start.
Yeah.
What a great start.
Yeah. Great
Amazing.
start.
Nope, we don't want that one. All right, well now it is time for us to welcome Jameeka Marshall, program manager for Shadow Scientist. Come on up and join us, Jameeka. Thank you so much. Yeah, Jameeka, welcome to All Space Considered.
Welcome.
Welcome.
Thank you.
You're very welcome. Yeah. Jameeka is program manager of Shadow the Scientist. It is a project that she's going to tell you all about, so I won't spoil any of the fun. But it provides folks like you an opportunity to connect with scientists, and not just connect with them in a venue like this, connect with them while they do their work. This is something that was not possible in the past. Scientists were sort of off in their labs doing their work mysteriously, off at the top of the mountain observing the heavens. Well, Jameeka and Shadow the Scientist provide an opportunity to connect with those folks as they do their work. So thank you so much for joining us at All Space Considered, Jameeka.
Thank you.
Yeah, I can't wait to hear all about this.
Well, thank you so much for having me, David. It is a pleasure to be here in the Leonard Nimoy Auditorium. I'm a huge Trekkie, so I took like 10 pictures outside with the sign behind me because I was so very excited. Yes, thank you for that amazing introduction, and it is a pleasure for me to be a part of a program that connects the community with scientists as they are conducting research and doing activities related to that research live and in real time, virtually, so that you can join from here, your car, wherever you are. So a little bit about Shadow the Scientist. We'll see that here in our visual story, which was produced by Westcliff Creative in the Bay Area, and it's going to feature our founder of Shadow the Scientist, who happens to be here right now, Raja Guhachakursa. That's right. Distinguished professor of astronomy and astrophysics at the University of California, Santa Cruz.
Astronomers have had the privilege of using modern telescopes around the world, but the COVID-19 pandemic put an end to physical access to mountaintops and physical access to university campuses, as a result of this temporary shutdown, a new mode of observing was born called pajama mode observing. Astronomers like me could sit in the comfort of our living rooms and operate telescopes around the world using the power of virtual network computing and Zoom screen sharing from our laptops. I saw this as a wonderful opportunity to engage students and educators around the world in the process of critical thinking and evidence-based reasoning that every scientific research goes through.
Shadow the Scientist is a virtual platform that allows us to connect the community with scientists and leaders in STEAM fields.
Good morning. Hey, Rebecca. Oh, thank you so much for having us out here to shadow you today and your team.
Okay, I'll read the tag number on this avocado. All right, Becky, so this one's going to be 2661. Yeah.
Growing up, I didn't have access to scientists conducting research, and so I wish I had this access as a kid, and I'm really happy to be able to give this opportunity to students around the world. The importance of expanding Shadow the Scientist to a variety of disciplines, it offers youth direct insight into how these different professions work. This way they can make a more informed decision about what career they wish to pursue.
This is the noni, one of our outplants, non-native, non-invasive.
I got involved in Shadow the Scientist because it's a chance to tell our story, to get out to a broader audience, to see the kind of work that we do in tropical forest ecology, what we do in conservation, and to share these special ecosystems of Hawaii with other people who may never be able to get out in the field.
It's a super fun experience to host one of these things. You're doing the science doesn't suffer. You're working with the instruments, the instrumentation is exactly the way that you were doing it before. All you do is you have another Zoom session, and you get to talk to some really passionate people along the way. So when you're in between exposures or things like that, you get to talk to people and explain what you're doing. And we like to explain what we're doing, so that's a lot of fun. It's real. It's live. It's happening as it's happening. If the night isn't going the way we expect it to, you get to see that and see how people respond to that. If the night is going exactly the way that it should, you get to see the excitement for that. And so it's not manufactured. It's not a couple of sentences in a book. It's not a web page. It's real science happening in real time.
A program like Shadow the Scientist is so important because it gets people connected to science, and most people don't understand or know enough about what scientists do, and we need to get more people excited about science and what's involved.
These sessions have the capacity to truly inspire our participants, not only just the students, but everyone as they consider how they can best contribute to their communities now and in the future.
That's beautiful moonset.
That is a beautiful moonset. Yes, thank you.
So now, what were the folks doing in the field? Those were biologists?
Yes, actually. So that is Dr. Rebecca Ostertag of the University of Hawaii at Hilo, and she does tropical forest ecology, and she was actually introduced to me by my friend who happens to be here right now, Joanna Norton, and that was her research advisor. She also happens to be my neighbor, and so it's incredible to be able to showcase the kind of work that she does. We're talking about conservation, and in particular, conservation work in Hawaii, which is where I live on the Big Island of Hawaii.
Now, so that's fantastic for the conservation work in biology, but there's also just a handful of big telescopes there as well. In my opinion, it is the most fantastic site to observe from on Earth. It has some of the best seeing, the best conditions, the high altitude, all of that is just wonderful. and yet astronomers open up their sessions and just like was said in the video, they just communicate with people.
Absolutely, this is so true. And so I'm very grateful to be able to work with amazing people who want to share their science. Shadow the Scientist does not work if people aren't willing and interested in sharing their research, if they're not willing to be vulnerable in front of a live audience. Because as that was Dr. John O'Mara, the Deputy Director of the Keck Observatory, talking about if the night isn't going well, if there are mistakes, you're going to see that in our session. If things are going well, you're going to see that too. It's not scripted. It's not a few words. It's not a presentation. It's live science happening in real time. So you get to experience all of that, the communications, the thinking that has to happen with all the team members to resolve any issues that could be happening.
So how do people connect? They said it was a Zoom session. Do you just join? Do you sign up? How would people do that?
That's right. Thank you for asking that. And so here on the Shadow the Scientist website, you can find all of our upcoming sessions. So here we have the April sessions. Now, we have two different kinds of sessions. We have public sessions, which we have, where is Rob? That's Rob. Yes, Rob and Stacy. Rob and Stacy. Rob is in almost every session that we have, and this is my very first time meeting Rob in person. So how do you sign up? Well, we send out an email to those people who are signed up for our mailing list, and if you aren't signed up on our mailing list, you can find us on our Shadow the Scientist social media platforms on Facebook, Instagram, and Blue Sky, and also right here on our website. And so here you can see we have upcoming sessions, and these say dedicated. A dedicated session is a session that is for a particular group. So if you're, let's say you're running a summer program and you'd like to have a biology session for your middle school, high school students, then they would be the only ones in that session so that they are comfortable talking amongst their peers to the scientists. They have familiarity with those around them, so that limits that barrier that sometimes can happen with nervousness when you don't know everyone in the virtual audience. And so these dedicated sessions are really special because I really decrease the security settings. I let you turn on your microphone. I let you turn on your video so that you can actually interact with the scientists in a way that in our public sessions you aren't able to do. You can only put comments and questions in the chat in public sessions. But that's, of course, for the security of everyone. Yep. And so our website has all of our sessions, and what you would do, you would just click on the register now, and then you'd have a page where you just go ahead and submit your information. It asks for your name, email address. There are a few questions. You click submit. You'll get a Zoom confirmation email that you can just click join now when it's time for the session, and then bam, there you are from wherever you happen to be, whether you're in your car, you're at home, or if you happen to be like in Hawaii where I have sessions, if you're there, then it certainly is also possible for you to join us in person, which is really, really awesome. Yes, so if you're in Hawaii, let us know.
And you moderate things also in such a way that I feel, even though it is not a lecture, there is a nice kind of flow to the session. And I guess because you've also seen how all these different, maybe in astronomy, observations take place in a certain kind of way. And so it's nice to have you also, it's not just someone behind a screen, for example, with astronomy, showing you what you can see on the telescopes. But Jameeka is there to also help you understand, because sometimes observations they're almost always very time limited, and so you have X amount of time to conduct your observation. You might be stressing, you might be like, oh, I gotta get this object. And so it's nice that you are there also to moderate and to ensure that both people have an intermediary and have a kind of way of going about things and of disseminating the information. Yeah.
In fact,
thank you.
I think you have some examples.
I do have examples.
So,
examples. Yes, thank you. That was a great segue.
Great segue.
Yes, thank you. Okay, so So I'm going to start first with Lick Observatory, which is, of course, a part of the University of California Observatories. And this one is featuring Dr. Matthew Citrone, the Deputy Director of University of California Observatories, as well as Evan Carrasco, a University of California Santa Cruz student. And this session, the title was Exposing Hidden Sources of Carbon in Our Galaxy. It's about 2 minutes long.
Okay, that's the cue. So they're ready, and so Evan is going to push. Good catch.
Do you want to change the observation number at all?
No, I think it's fine.
Okay, so I'm going to click this button here, start exposing, and the camera's going to turn on, and it's going to collect the starlight.
Oh, this was Lick, you said.
Yeah.
So we.
Oh, go ahead.
Go ahead, Evan.
Oh, well, I'll just say when I click the start, you'll hear these dings and chimes that's coming from our computer. It's a system put in place to keep astronomers awake when it gets to the
and there's a whole variety of those sounds that you can program that are, some of them are great.
Have the voice memos going so you know what step you are on.
It's like a video game.
So we just finished exposing, and now the computer's going to read out the image that we just took.
I think it was a star.
Here's the top is the blue part of the spectrum here, and so the star is here. This back here is the sky, and you can sort of see the sky is still very bright, and but you can sort of see all these little not black holes, that's probably the wrong word to use with this crowd. These little black marks on the detector. And that is flaws in the optics and in the detector. And so we can calibrate that out with our flat fielding so that they make almost no difference.
And so I wanted to start with Dr. Citrone and Evan Carrasco because we are a program that's based out of the University of California, Santa Cruz, and we certainly do our best to work with professors across all fields at the university, and that's an ongoing effort, absolutely ongoing effort. But you got to see that not only do you have seasoned professional scientists in our sessions, but we welcome students in our sessions as subject matter experts. And through, we are generously funded by the Heising-Simons Foundation, and that allows us to pay a modest amount, an honorarium to students, undergraduate and grad students who serve as subject matter experts in these sessions, not only to, of course, compensate them for their time, but to show them we appreciate their expertise and effort because they are in school. Yeah. They're in school, they're also working regular jobs as well too, and taking the time while they're doing their research to be with us and talk us through the process that we're observing with them, like Evan just did.
And you yourself, you are a subject matter expert in astronomy. Of course, your background is in astronomy, and I'm curious what, with the breadth of all the disciplines that Shadow the Scientist has covered, what were the ones that for you were the most, which ones wowed you the most that were not things you were accustomed, because we're all, of course, anyone who looks at this is like, wow, that's what they do at an observatory, that's what they look like. Yes. And I'm curious what was that experience for you with maybe another scientific topic?
That's probably going to be the session with it's the geology sessions with the Hawaii Volcano Observatory. Wow. Have you all heard of Kilauea? Mm-hmm. Yes. And so you probably are aware that Kilauea, since this is, I guess,
a year
or so, year and a half, has been erupting almost regularly every 2 weeks or so. Just last week before I left to come here, and we have the huge lava fountains and tephra everywhere. And so I think that is probably one of my favorite sessions. Yes, and we'll get a sneak peek of that here coming up.
And we can go back and watch these on YouTube, right?
That's right. Yes, right. That's right. And so in my last slide, I have a link to our Shadow the Scientist YouTube channel. But if you just go to YouTube and type in Shadow the Scientist, you'll see our channel. Yes. So from Lick Observatory, which is of course on Mount Hamilton, we go to the Chara Array. How many of you have heard of the Chara Array, which is right here above LA? A few of you.
Someone is here tonight. He's not in the room. Who is one of the operators? One of our colleagues, Evan Renteria, is one of the operators of the Chara Array.
Oh, so. Evan. Okay, Evan. Wonderful. And so we, within astronomy, of course, there's different modes of observing, different types of observations that you can take, different types of observatories, from radio to optical, infrared, submillimeter. And so Lick was optical. Here we have an interferometer. This is the Chara Array. This is the Center for High Angular Resolution Astronomy. This is actually Georgia State University's flagship program in their astrophysics department, but it is located right here.
Right here, an hour north of
Mount Wilson.
That's right.
People don't realize we do observations from the Los Angeles region.
It is, you might think that's surprising, but it definitely does happen. And Mount Wilson, of course, is historic for many reasons.
Super important, yep.
Absolutely. And so here we have this session with Dr. Nick Scott and Dr. Cyprian Lantherman. It was just a few weeks ago, and it was for the Los Angeles Pierce College, community college here, right in your backyard. And I see someone waving up there. Okay, great. Yes, yes. So we, part of our goal here, our aim is to provide connections, especially to for students and universities, colleges who are under-resourced, and community colleges tend to fall into that category. And so we had this session for their STEM week, which was just a few weeks ago, and it was our first time working with them, and it was fantastic. Take a look.
Yeah, and that's just the telescope side. Those are the instrument side that have kind of the same. So here we have one that separates between two different wavelengths. So the K-band for MYSTIC and the H-band for Merkix, which allow us to have different information at the same time, because we are observing both at the same time. Then the light is picked up for Merkix and sent on those mirrors, that is then sent in polarization plate, because polarization is actually very important for the fringes. If you don't have, if you have a mismatch in the polarization, your fringes will have a very low contrast, and so we need to correct for that, especially because we are using fiber optics in most of our instruments now. Yeah. So as you can see, the light comes, hits this mirror, and we'll need to focus this mirror on the tip of the fiber optic to get as much light as we can in this fiber optics, which then are sent in the camera with different purposes.
So, you know, in these sessions, not only did we get to actually see the science happening in real time, astronomy for this one in particular, but we get to go into the lab, actually where all of the lights, all the optics, all their instrumentation is. And Cyprian did a fantastic job. He was answering a question that we had from one of the students, so you didn't see that part. But this was in response to how do you optimize capturing all the photons, and how do you manage with all the reflections of the light that has to happen with interferometry. And so that's what we heard Cyprian answering there.
Yeah. So folks, so you know what they're doing, interferometry is where you take separate telescopes and you combine the light to make an image that has a resolution as though the mirror were as big as the separation of the two separate scopes. So it's sort of a trick that radio astronomy has been using for a long time, it just gets harder and harder to do as you get closer and closer to visible wavelengths. The CHARA array is doing it in the infrared, and it's just insane. They're able to see images of stars, like the surface of a star.
Yeah, we showed some, in fact, in February, because they actually resolve star spots, so sunspots, on other stars, which is incredible.
Just incredible. So folks can tune in, and this time they were showing the instrumentation there, but there are times they're taking images and you'll see a star's surface.
Well, yes, that's right. You can, after they do lots of data reduction. Yes. And so Cyprian here mentions fringes, because that's what the raw data here are fringes, and then further, later on they talk about how they extrapolate that to data. It's like the how light or how dark the fringes are and how close together they are. All of that makes a difference, and so definitely check out our YouTube channel to hear more about that. So we get to see different types of astronomy happening.
But now you have some footage of another run of somebody that maybe is a little closer to All Space Considered.
Let's see. I think so. Yes, that's right. So our very own Laura May and Ron here. Yes.
I don't know if Bryce is here.
Bryce.
I'm not sure Bryce was going to maybe be here.
Oh, yes, there's Bryce.
Dr. Boland has been a guest here at All Space Considered before, talking about his work, but also participates with you, Laura.
And I'm lucky to be with Bryce to do this, and especially because of the nature of what we observe. It's nice because it's very dynamic. And you have limited time, and you're like, oh my God! Well, I'm not going to spoil it.
Let's take a look.
Let's just jump in. And so this is Dr. Bryce Bowen of Eureka Scientific, Laura Mia Braun of Griffith Observatory, and Matthew Belyakov of Caltech in this session at Keck Observatory, testing the taxonomy of Neptunian Trojans.
Was this the one from this year or last year?
This is
last year.
That's been written about it. But I do want to say regarding YR4, I don't know if Bryce already spoke about it, its size is approximately similar to what would have caused the Tunguska event.
Tunguska.
Yeah, that's right. Please correct me. Which crashed in Siberia in, I think, 1903 or somewhere around that time. And so, whilst it would cause a lot of damage, it's not a civilization.
Oh, hey, there it is. There it is. Yeah, there it is. Oh, you can see it. There it is.
Wow. I think this was also when we had this issue. Yes. So I'm pretty sure if this was the one from last year when we had an issue with the detector and it was reduced in size and there were all these issues. And so you're super excited. Yeah, I mean, I love that Bryce conveyed this greatly, because also it's a tiny little pixel, and Bryce has a very sharp eye for spotting these things. I'm still like, where? What pixel? Like, there's stars, there's things. And so it is really exciting when you find them. You're so excited, especially because YR4, I think these were the last. So this was an asteroid that was going to potentially crash on Earth, and then it was found that it might crash on the moon, which not great for lunar missions. And then eventually that was rolled out recently.
Sure was.
But those, I think, were the last Earth-based observations of it. And so it was super, super faint, and you're so excited if you actually get it.
So that doesn't happen all the time in these sessions, of course.
Screaming
and excitement, but it can.
All the time.
It can, but that's how astronomy and observations go. Sometimes you make discoveries real time, or you catch your object, or you reacquire it. So there are exciting moments throughout all of this. For you, what was the most exciting that you've seen?
Well, the most exciting session that I've been in, so this was really exciting, and first, I am so grateful again to work with such amazing collaborators. You get to see that passion and enthusiasm come out. Science is fun. Science is fun. Science is interesting, right? And I love that you get to see that authentically happen when you finally get the object centered in the slit that you've been looking for. But also, and what you don't see is what's happening in the chat with our audience. So 2024 YI4, there were so many news articles out about it, a lot of misinformation. And so we had great questions in the chat about that to get clarity and understanding from people who are actually doing the research. And that's one of the great things about Shadow the Scientist. You don't have to guess at what's happening. You don't have to read an article and not be sure if it's true or not. No, right here you can ask the experts and connect with them and build lasting connections.
Which in fact during 3i Atlas, that session that I think we did earlier in the year, there was obviously also a lot of things written about Interstellar Comet 3i Atlas, and it was really nice to get to talk to people, and they were like, oh my gosh, we get to actually see it in the detector and ask questions, and so that's, it provides another point of contact, which is nice.
It does. So one of my favorite astronomy sessions is coming up, and you were talking about 3i Atlas, of course, our third interstellar visitor. And again, as you said, so much out in the media about it. And this was a very full session. Now, with Shadow the Scientist, we were just privileged to have 4 observing sessions with 3i Atlas, with Laura May and Bryce on Keck Telescope, with Dr. J.D. Armstrong at Las Cumbres Observatory, and again here with the International Gemini Observatory, which is operated by Lab, Gemini South here in Chile. And so here we have Dr. Karen Meach of the University of Hawaii at Manoa, Dr. Brian Lameau, Gemini Observatory North and NORLAB, Emily Peavy as well, Pierre King, who is I believe he's in the observer seat here for this session, and Carlene Silva is the operator. And we'll get a lovely raw view as the images are coming in real time of 3i Atlas. Let's take a listen.
Brian, we have the first image. It's very nice.
Oh.
Okay, everybody.
Oh, nice. Yes, look at that bad boy.
That was exciting.
Nice tail. You can figure out who's all the nerds on the call because we're all like getting in there.
Very cool. This is even in the band, I think, right? So, okay. Wow, it didn't look like that last time. I saw it. And this is, keep in mind for everybody, this is a raw image. So this is not even this is just directly from the telescope right now. It still has all the defects. You can see all the various vertical stripes and the gaps and everything. That orange thing isn't real. That's not on the detector. That's just a
It's not in space, I promise. No yellow squares.
The background stars, and you can see the comet right in the middle there. So yep, we're there.
So Karen, one thing go on, Karen.
You're looking at a piece of what would have become a planet in another star system. And we will never know where it came from because it came from a long time ago and there's so many stars out there, but this is a building block from somebody else's home.
Which is mind-blowing here.
Like that phrasing.
Yeah. I heard actually, Karen, that there's some supposition that it came from the thick disk of the Milky Way, so that it may even predate our solar system.
Yeah, that's possible. The problem with tracing it backwards in time, no matter how accurate you measure the path, is that everything is moving. And so it's not just about measuring the path of this object accurately, but it's knowing the paths of all stars accurately. And everything has errors in measurement. And so the farther away it gets, the errors build up, and eventually there's too many errors. You can never figure out exactly where it came from.
And so, this was 3i Atlas. It's still big. I saw an article just the other day about how much water it's spewing out on its way out of the solar system.
And on this call, sorry to interrupt you. Yes. On this call was Brian Lameau, who, by the way, discovered 3i Atlas and YR4 and a whole bunch of other objects. So you get to actually have access to people who are making huge discoveries And that, yeah, it blows my mind that it's, you know, you get to just talk to these people directly. I think as a kid, I would have been like, oh my gosh, like this is incredible.
Yeah.
You know, it really is. And being able to, first of all, see the raw image, because a lot of people don't realize that those lovely pictures that we see that are in color and they're all sharp and focused, that is not how they originally started. Okay? A lot of effort goes into that, as Laura May and Bryce, you know, can tell you. A lot of effort goes into creating that, so you get to see what these images actually look like when they first occur. But also, you heard Brian answering a question because we had a very lively chat going, and actually, Bryce was also in that session because he was having a session, I think, the next day or the next week following, and so he was a part of that session as well. But Karen's, Dr. Meach's response to, like, why can't we just trace back where it came from? Because that's a logical thing. You think, why can't we do that? And I thought her response was just perfect.
That was really great.
Was just perfect.
Just perfect.
Now, I think as one of your last examples, you added the volcanology one.
So as Raja actually mentioned in our introductory video, I came on in 2023, and of course I needed to get accustomed to everything, but one of our first directives was to really start to broaden our horizons beyond astronomy. And I love astronomy, but I also love science in general. And I never thought I could actually study all the sciences. I thought I'd have to just pick one. But in this position as the program manager for Charlotte Scientists, I get to work with scientific experts in all kinds of fields, including volcanology. But let's see what we have next. I pulled out a few here. So before volcanology, I'll point out oceanography. So we really do try to have sessions that appeal to everyone, and in particular, focusing on oceanography is one that I absolutely love. I'm a Navy brat, and so I love the water. I love ships, and living in Hawaii, I also love the ocean. What's going on down there? How do we study it? And so here, the crew of the JOIDES Resolution are actually exploring Earth's paleoclimate. And yes, this is live. When we did this session, we were doing ship to shore, right? Ship to shore. So I'm not on the ship. It would be great if I were. But they were in the middle of the Mediterranean, so it's a little far from where I was. But they set these sessions up to interact with classrooms, with students, with the public who are interested in seeing not only what it's like to live and work on a research vessel for months at a time, but also to do the science. What is it like to be a scientist on board this vessel doing research? And let's hear what they have to say.
Hi, my name is Agatha, and I work at the University of Catania, which is in the southern part of Italy. My role on board is to provide age determination according to a special kind of microfossils, which are called calcareous nanofossils. And they are very small, but they are quite powerful because they can provide very useful and specific age determination for segments. If you want me to show something, I will say yes, please.
Yes, please, show us something cool.
Prepare samples for the analysis because you make this thin section, which maybe you believe that nothing is inside because these fossils are very small. The size is about 10 microns, and you must consider that the 1 micron is one millimeter, the millesimal part of 1 millimeter, so they are very small. But we have the opportunity to have this very nice microscope, which can provide magnification of more than 1,000 times. And then if we put this in under the microscope, maybe we can see something like this. I will show you if I found something. Now, image, yes. maybe we can have this very nice sky with all these stars.
Fingers in the
You
way
see?
of cameras, sorry.
We have this very nice, they are here, yes, in this, in this, if we put under the microscope, we can have these very nice images, which are stars which lived about in an ancient sea, which is about 3 million years old. And maybe if it's amazing, and if you want to see something else, okay, I will try to show you. And maybe this one is very nice. It looks like small butterflies, and they are again calcareous nanofossils, which provide an age of 6 million years for this sample. So this is my job on the ship. Was because we are at the end, we are going
they're at the end of their expedition.
Thank you so much, Agatha. Thank you so much.
So yeah, these microfossils. So I knew what microfossils were, but to know how they use the microfossils to age the sediment. And so that was really what was going on in this session. And actually, further in this session, we can actually see them making the cuts of the core samples, and they talk about the aging and how they use part of it for current study, and then the rest is put away for future generations, like for decades, so that there's always something that's fresh, that hasn't been touched and opened to the atmosphere that people can study in the future. So this was definitely one of my favorites. And then yes, so actually I think I have the Hawaii volcano one after this one. And so biology is another big one. And of course, biology is a required high school course. And so this session is with two brilliant young ladies at the Massachusetts Institute of Technology, Michaela Capage and Jessica Bonner. They are looking at Michaela in particular. This is her research, and Jessica is supporting and explaining to us what Michaela's doing. She's looking at the Drosophila ovary as a model system to investigate how egg stem cells proliferation is controlled. First, I loved the colors that we see here in this ovary, and then she talks about how she dyes them, how they're stained, and why that is. But here she's going to be answering a student question, and this is Mr. Woodbury's class in a local high school who's asking a question here. This is an AP biology class.
And Drosophila are the small little fruit flies,
Small
right?
fruit flies, exactly. Thank you.
I know that you're.
Okay, so this is a little faint, her question.
Around or remove genes that you think might
but
be
Michaela
responsible
restates it.
for the, I guess, change in the number of eggs. So, like, what kind of, like, I guess, like, what's, like, the thought process you go through of, like, picking which gene exactly to, like, edit or change? Like, why you that one's supposed to use?
Great question.
Yeah, like how did I land on this gene that I'm interested in testing, and why am I not testing another gene, for example? Yeah, it's a really good question. I'd say two things. So one, part of the, I'd say one thing to start, which is that Drosophila melanogaster as a model organism is really, really, really powerful because you can test many genes at one time. And you can test many different genes in one experiment.
So this is the
the lab that I'm in, my boss is actually pretty famous for these just giant experiments where she will just test, or where people in her lab, people who work in her lab, will test just like 150 different genes. And you can get away with this because Drosophila grow so quickly, they're so cheap, all of that. So part of the answer is that you don't necessarily need to have a really good reason for testing all of your genes. This is a type of experiment that's called a screen, because you're just rapidly screening through many different options to see what comes out, basically. And this type of experiment is like totally not feasible in mice. It's not at all feasible in most other organisms. But flies are so cheap and so fast and so easy to work with that you can kind of get away with
flies.
Flies are cheap.
So that's one answer, which is that people who work in Drosophila tend to just test many different genes all at once.
Yes, flies are cheap.
Yeah.
Flies are cheap.
Flies, we salute you.
Yes, we do appreciate you. But this is an example. This is a great example of one of our dedicated sessions. The students, the students can have their camera on. The teacher does, Mr. Woodbury, and they get to connect and ask these questions directly to our science guests here. And they had just finished the AP biology exam. So they, they were having a break because they were pretty much finished with the school year. I think this was maybe late April. And so they had great questions, and it was wonderful to see this and to hear this because they were very, they already understood what was going on. She's using confocal microscopy here. I believe that's correct, confocal microscopy. And what we see here in the image is the telescope that she's using. It's huge. It's huge. And at the beginning of this video, some of the students asked, like, how did she get this training? I believe this is the Lehman lab, Ruth Lehman lab here, and this is like $1 million piece of equipment, and she talks about how nervous she is and using it, and how everyone gets a certain amount of training, but at the same time, you have to do your work. You have to build that confidence around using it, and sometimes things happen, and you have to learn to deal with that. And so the students had great questions around that. And so, yes, here we are. So I love volcanology. It is a privilege and a pleasure to live 30 miles away from one of the most active volcanoes on the planet. It's always something interesting happening. But here, I was so privileged to be able to have this session with Dr. Kendra Lynn, Heather Winslow, Bailey McDade, Kamalani Po'e, Nomi Barnett, and Abigail Nalisk of the Hawaii USGS Hawaii Volcano Observatory. And so so they actually go out to the actual site, out into the crater. They are helicoptered in, and they can get actual lava samples, and they do lots of research on it. And so we're going to see here Kama getting some lava and showing us what these bits of lava look like under the microscope, and what we're actually seeing.
These samples. This is Kama. She's been an intern here with us for the past year and volunteer. She's great. She's been working along with cool data sets. And she's going to show us how she picks through these grains, finds the crystals to separate so then we can take it to the next step. So, yeah.
Hi, everybody. If you guys come over here, I'm going to share the screen so you guys can have a better
So again, these are all students here in this clip.
Okay. Can you guys see what's going on? Oh, there we go. Okay.
That is gorgeous.
So this is the 1 to 2 millimeter size that Heather was talking about, and we kind of look at these to see where the olivines are. So right now, this is one mode of how we kind of view to find these olivines, and this is where the magic happens. So I'm going to turn this off. This all the way up.
Meteorite. We have some olivine right outside this door, by the way, in meteorites.
So we need to take a look when we finish. Yes, yes.
There we go.
Look at that.
So as you can see,
and this is fresh lava, right? That was collected a day prior, I'm guessing.
I think this was a week prior.
A week prior,
yep. To see all of these, like crystallite.
Wow.
Like this is an olivine right here.
Tiny.
This is an olivine. And then the rest of these over here, like surrounding it, is just glass. So we kind of just like sift through it, pick it. So this is one.
We have some olivine lovers in the audience
this is
tonight.
Like really shiny. I call this gold, because it's basically gold. And yeah, so yeah, we kind of just sift through it like that and gather all of the olivine. And once you get all the olivine, we put it in like a separate dish.
This is like what we train for as children. You just separate little
And
shells
this
or little
is
things.
all of
and
the
it's
gold that I
incredible.
found.
It is.
So I'll pause it right there. So Kama and the whole team, they took us through the steps. We didn't, of course, we weren't able to see them actually taking the samples. I do hope to be able to get that at a different time in the future, yes. But we got to see them do the whole process. There are 5 different steps here, and this is step number 2, I believe. So definitely check this out. It's so interesting. And then they go into what they're looking for in doing this research and how this helps with their ongoing understanding of not only volcanology in general, but Kilauea specifically, because right after this, it really started to change. And this current eruption cycle of every couple of weeks is new. It has never done this before. So what's happening? What's changing? And you really get to hear them explain a lot about this in this video.
That's amazing.
Just amazing work that you're doing to bring all of this to the public. I think we have time for just a question or two, if folks have any here in the audience.
Especially if there are any students in the audience who have questions about...
here, right over here.
Yes.
Over here on the right,
yeah.
As a mechanical engineering student, do Shadow the Scientist actually help students gain experience with hands-on like projects or whatever with the scientists?
That's a great question. So not directly, only in the sense that we can, through these kinds of sessions, or if you connect with me, we can put you in contact with them so that you can ask them yourself if what kinds of opportunities that they have. But we certainly want to facilitate those kinds of connections. Absolutely. And of course, as students, an undergrad or grad student, we would love having you on the show as a subject matter expert. So if we were doing some instrumentation, for example, which we'll have a couple of sessions in the summer, instrumentation coming up with actually students in Canada, grad students in Canada, and this is exactly what they're doing. They're doing an internship, but they're going to be using Gemini data. And that happened through a process where Dr. Brian Lameau and others had connected with the professor, and then they got this opportunity. So through that facilitation process, we do support that kind of an outcome. Thank you for your question.
Yeah. So, question: what is the next session that's coming up?
The next session coming up is, David, look, I have to look. Okay, April 20th is actually another session with Michaela Capage and Jessica Bonner, and this is a session for, this is first and second year chemistry and biology students at Ashoka University in India, because Shadow the Scientist is international, everyone. Yes, clap for that. Yes, thank you. It is international, and so no, we don't just work with students and communities and scientists here in California, and not just in the U.S., but all around the world, and we're looking to expand that. So students, professors, teachers, parents, people, please reach out to us. We are looking to serve your community.
Antarctica, reach out.
Oh, yes.
Artemis astronauts also.
Yes.
Please,
yes.
we do a Shadow the Scientists
Victor.
on the moon.
Victor, yes, Victor, especially, yes.
Let's give Jameeka a thank you again for joining us. Thank you so much for joining us tonight.
Thank you so much. Mahalo.
So folks, that's our show for tonight. Thank you so much for joining us tonight at All Space Considered. We'll be back next month with another show. And again, All Space Considered is brought to you by the City of Los Angeles Department of Recreation and Parks. And as always, we thank our exclusive nonprofit partner, Griffith Observatory Foundation. We'll see you all next month, everybody.